Okay, Assalamualaikum warahmatullahi wabarakatuh, and hi to all of you. So today we will discuss chapter 7, geometrical objects, what the mirror and also the lens. So now look at for the first question. We have an object of 0.60 centimeter tall is placed 15 centimeter to the left of the vertex of a converging mirror having a radius of curvature of 24 centimeter. Determine the position and size of the image. So you need to solve two questions, which is identify the position of image, means the image distance, okay, the image distance, and second is the size of image, height of the image. Okay, so as usual, please list out all the information given. Okay, we have the height of the object 0.60 centimeter, and it was placed about 15 centimeter to the left of converging mirror. Okay, and the radius of the mirror is 24. Okay, be careful with this value. For the radius, it can be as a positive and negative sign, and it is depends on the type of mirror. And this one is about you punya converging mirror. Okay, so converging mirror, your R is a positive 24. Okay, converging mirror ini stand for concave mirror. Okay, concave mirror. Because converging is menumpu, okay? Alright, so this all the information that you have, and we want to determine the image distance and also height of image. Okay, so it's simple because you already have the object distance, radius of curvature, and we want to find the image distance. So we just use the mirror equation, which is 1 over f equals to 1 over u plus with 1 over v. But then we have the radius of curvature, and as we know, the focal length is radius of curvature over with the 2. So once you substitute into this equation, it is become as 2 over r equals to 1 over u plus 1 over v. Okay, now guys, to use the mirror equation, you need to set your mind all this value, it can be as a positive and negative. Okay, your f can be positive or negative, your u also can be as a positive and negative. Same goes with the v and the radius of curvature, because for the mirror, okay, for the mirror, r and f was together. If the r is a positive, means the f also positive value, just for the mirror. Okay, so we substitute the values. 2 over with 24, positive 24, equals to 1 over object distance 15 plus with 1 over v. Therefore, the image distance we get 60 centimeter. Okay, so this positive value of image distance stand for real image, okay, real, inverted, and also form in front of the mirror. Okay, settle for image distance. Okay, now we proceed with height of image. Okay, for the height of image, I use other side. Okay, to find the height of image, because you already have the height of object, right? Okay, so you can use the relationship between hi over ho equals to negative v over u. Okay, that negative is the equation, okay? Please do not ignore the negative of equation. So then just substitute the value hi over with height of object is 0.60 centimeter equals to negative, and the v just now we get a positive 60 over with the object distance 15 centimeter. Okay, therefore we get the height of image is negative 2.4 centimeter. And as we know, for the height, okay, the measurement of the height, there is no negative value. Okay, this negative actually stand for inverted image. Okay, inverted image. So you can compare with the previous calculation. Okay, and also real lah. Okay, because you get the V is positive 60. So positive 60 is real and inverted image. So correct. Okay, you get the height is negative 2.4. Okay, so we make the conclusion H of image is 2.4 centimeter. Okay, settle for question number 1. Now look at to the next question. Okay, question number 2. The left end of a glass rod 6 centimeter in diameter has a convex hemispherical surface. The refractive index of the glass is 1.60. Determine the position of the image if the object is placed in air on the axis of the rod at a distance of 8 centimeter from the surface. Okay, surface of convex. Okay, now it's better for us if you sketch a simple diagram because you have a convex. Okay, convex is gemuk. Okay, so this is the convex surface like this, and you have the radius for that surface about 6 centimeter. Okay, so we'll list out the information given. You have the end for the glass 1.60. Okay, and your object was placed in the air, and of course you have end for the air 1.00, and you have the object distance 8 centimeter. Right, and your R, okay, your R is 6 centimeter. Sorry, not R, this is the diameter. Okay, so if the diameter is 6 centimeter, therefore the radius is 3 centimeter. Okay, this is our principal as is, and let's say this is your object. Okay, so that's your object. Okay, in front of the surface of convex. So then this R, okay, this R is a positive. Okay, because your object facing the gemuk one. Okay, the facing the convex surface. Because convex is gemuk. Jadi maksudnya awak punya objek dia facing permukaan yang gemuk. Okay, so gemuk maksudnya awak tengah kenyang. That's why your R is a positive. Jadi dekat sini, okay, we put the positive sign of R lah. Okay, as the precaution, and we want to determine the image distance. Okay, the V. Okay, so simple. Just apply into your equation. We have N1 over with the U plus with N2 over with the V equals to N2 minus N1 over R. Okay, now you need to identify which N is your N1 and which refractive index become as your N2. Okay, now look at to the diagram, our simple diagram. Right now, your object was placed in the air. Okay, it placed in the air. Means your N1 stand for refractive index of air. Okay, sebab N1 itu represent awak punya incident ray. Okay, incident ray ini dia comes from the object. Okay, incident dia comes from the object. So that's why incident you occur in the air, and N1 is N for the air. Okay, then refractive index of the glass is our N2 lah. Okay, N2 because N2 occur the refraction. Okay, the refraction is occur inside. Okay, ini refracted. Okay, refracted. Okay, alright. So substitute into the equation. So N1 is 1.00 over with the U is 8 plus with N2 is air 1.60 over with the V equals to N2 is 1.6. Okay, and minus with N1 adalah 1.00 over with the radius a positive 3. Okay, just use your scientific calculator. Therefore, you can have the V equals to 21.33 centimeter. So from this value of image, we can identify. Okay, identify the image characteristic. Okay, image characteristic because it is a positive. So positive means real image. Okay, real image inverted. Okay, real inverted and form inside the glass. Okay, inside the glass because this one is the refraction. Refraction mesti occur dua side yang berbeza. Baru image itu jadi real. Okay, refraction is tembus. Okay, settle for question number 2. Now look at for question number 3. A 2.5 centimeter tall object is 9.5 centimeter in front of a diverging lens that has 8 cm focal length. Use a ray diagram to find the position and height. Okay, so you need to sketch your ray diagram to identify the position or location. Okay, to identify the location of image form. Then you need to calculate the image distance and height of image. Okay, so we list out the information. You have height of object 2.5 centimeter and the object is placed 9.5 centimeter in front of diverging lens, and that lens has the focal length, okay, focal length about 8, but this is the diverging. Okay, diverging. This chapter you kena fokus dia jenis lens atau mirror apa. Kalau you tak fokus, you akan sesat. Okay, so the focal length is negative. Okay, negative 8 cm because of diverging. Okay, masa exam boleh tulis macam ni, tak ada masalah supaya kita lebih berhati-hati. Okay, so we sketch the simple diagram. Okay, for this one ray diagram. Okay, and don't forget our principle exists. Okay, please use your ruler, okay? And this is our F1. And this is, sorry, small f, okay? Focal, small f. Capital F stand for focal point. Small f is focal length. And this is our F2. And this one, double, okay? 2F2. And this is 2F1. Okay, so we place the object 9.5 centimeter, means more than the focal length. Okay, more than the focal length. So this is the location of object. Okay, we place right here. So that's your object. Okay, and the incident ray. Okay, the incident ray, it is parallel. Okay, because you have 3 rays. And to sketch the ray diagram, you can use at least 2. Okay, sekurang-kurangnya 2 to have the image form. Okay, you need to practice how to sketch the ray diagram, Kena practice sendiri, jangan baca nota. Okay, so this is our incident through the center of lens. Okay, and this is the diverging, okay? Diverging. So it can't be like this. Tak boleh. Salah. Because dia diverge. Diverge is mencapah. So supposedly dia jadi macam ni. Okay, so to have this one, you need to focus on, okay, as we know, parallel to the lens will be refracted to the focal point. So like this. Okay, so this is your refracted light. Okay, refracted ray. Okay, settle for first ray. Okay, baru selesai satu. And then for the second ray, okay, I use the center of the lens lah. Okay, so this is your second ray. And this is the incident and this is our refracted. Okay, my dear, please. Okay, sorry. Okay, please sketch the head of arrow. Okay, the head of arrow for incident and refracted. Ni, kena lukis. Okay, please lukis benda ni. Stand for incident refracted ray. Faham? Kena lukis. Tak lukis, habis awak. Okay, so now we can see the intersection of refracted. Okay, and this is the image form. Okay, so image is right here. Okay, we use the dotted line because dia adalah virtual image. Okay, virtual image. Okay, settle for the ray diagram. Now we go further with the calculation. Okay, calculation. We want to calculate the image distance. Okay, the image distance. Okay, saya use other side. So kita nak cari the V. Okay, so based on the information given, you have U, you have F. So just use the lens equation. Okay, lens equation. 1 over F equal to 1 over U plus with 1 over V. So our F is -8 because diverging lens equals to 1 over U is 9.5 centimeter plus with 1 over V. Okay, therefore the V we get negative 4.34 centimeter. don't forget your unit. Okay, unit is very important in physics. Okay, so as usual, we just state the characteristic of image. Okay, so when the V is negative means it is virtual image. Okay, virtual pair dia adalah upright. Okay, it is upright and it is formed in front. Okay, in front of lens sebab dia virtual. Okay, jika sepatutnya dia tembus, tapi dia tak tembus. Image you dia form in the same side with object. That's why dia adalah virtual. Okay, settle for the V. Now look at to the height of image. Okay, then how to find the height of image? As usual, we use height of image over with height of object equal to negative V over U. So height of image, okay, height of image over with 2.5, the height of object equals to negative K. This one, negative V is compulsory. Okay, don't forget to substitute the negative. Negative 4.34 over with object distance is 9.5. Okay, kenapa wajib? Sebab image kita is virtual image. Okay, compulsory. To use this one, V positive or negative, it is compulsory. Wajib letak. Okay, alright. Then you can get the final answer is 1.14 cm. Okay, so kat sini kita nampak the height of image is positive. When this is a positive, maksudnya image you adalah upright. Okay, is upright and virtual. So, betul sama dengan apa yang kita dah discuss earlier. Okay, the V stand for virtual, same goes with the height. Okay, settle question number 3. Next, question number 4. Okay, our last question. Okay, figure 1 shows a thin converging. Okay, sorry, typing error. Converging Okay, ada N kat situ. Converging lens with the refractive index 1.50 and you have two radii of 3 cm and 6 cm respectively is surrounded by air. You need to determine the focal length of the lens. Okay. Okay. So now, guys, first of all, you need to know which surface has the 3 cm radius and also 6 cm radius. And this question told us we use the converging lens. Okay, converging lens dia gemuk tau. Okay, so if you see through this lens, okay, to this lens, dia gemuk dekat sini. Okay, but for diverging lens, okay, diverging lens, the shape of diverging lens, it is like this. Oops, sorry. Okay, which is at this side, okay, at this side, it is macam thin, dia thinner, dia lebih nipis. Okay, so you have the comparison. Okay, so jangan tengok bentuk macam hafal, tak boleh. Salah tu. Okay, so this is the converging. Okay. Therefore, this surface, okay, this surface has the smaller, okay, has the smaller radius. So this is the 3 cm while this one is the 6 cm. Okay. And sebenarnya you pun boleh nampak. Okay. Okay, boleh nampak. Ini dia lebih flat. Okay, that's why dia adalah 6 cm. But this one dia more curving. Nampak tak? Dia lebih curve. Okay, so bila dia lebih curve, maksudnya dia lebih kecil lah. Okay. Sebab tu kena biasa jawab soalan. Okay, so we list out the information. You have the refractive index of the glass 1.50. Okay, and you have the radius 3 cm. Okay, and the other one is 6 cm. And this placed in air. Okay, it is placed in the air 1.00. Okay, so let's say I just use this diagram. Okay, let's say you have object at the left of the lens. Okay, so this is your object, and your object facing the convex surface. Okay, convex surface. Okay, so bila convex surface, maksudnya RU it should be positive. So ini adalah positif, ini pun adalah positif lah. Okay, sebab both surface are convex. Okay, both adalah convex. Okay, cuma masalahnya tadi saya dah terang macam mana nak tentukan radius mana yang lebih besar dan lebih kecil. Okay, next 3 cm become as R1 and 6 cm become as R2. Kenapa? Sebab kita refer to the object. Okay, refer to the object because object you facing 3 cm. Okay, so bila dia facing at this side, maksudnya inilah you punya R1. And this one is our R2. Okay, actually everything that depends on object. Okay, object you nak letak dekat mana. Okay, so then kita nak cari the focal length. Okay, of course we use the Lens Meka equation. Okay, you can use 1 over f equal to 1 over u plus 1 over v. Tak boleh guna because we do not have the value of object distance and image distance. Okay, tak ada. So tak ada, tak boleh gunalah. Okay, so 1 over f equals to n material over width n medium minus width 1. Okay, times width 1 over R1 minus width 1 over R2. Okay, and we have all the values, and material maksudnya n for the glass. Okay, so n for the glass is 1.50, and medium we place in the air. Okay, in the air. Okay, so this one is 1.00 lah. Okay, minus width 1 and 1 over R1 is positive 3 minus width R2 is a positive 6. Okay, just use your scientific calculator. Therefore, you can get the value of focal length is positive 12.0 cm. Okay, so betul lah. We get the positive sign because of converging lens. Okay, so betul. Calculation kita tu betul. Okay, that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.